Okay, first thing we do so we take the wet bulb temperature at the return grill. This is the wet bulb temperature at the return grill. Wet bulb temperature at the return grill is 72 degrees. Entering the condenser, 90 degrees. So we set our wet bulb temperature at 72. Indoor entering air wet bulb temperature is 72 degrees, so we set our pointer at 72. And then our condenser entering air dry bulb temperature is 90. So if you see on the 410A SuperHeat calculator at 90 degrees, we require 24 degrees of superheat. So right now I'm using my 410A gauges, and my 410A gauges say that we have a pressure of 110 psi, which coordinates to 36 degrees Fahrenheit is the saturation temperature. Now our actual temperature of our suction line, remember we have this down here, we have our thermocouple that's attached to the line. Our actual temperature of the line is 83.3 degrees, and our suction line temperature is, our suction line pressure has dropped to 105, which coordinates to a suction line temperature, saturation temperature at 105 psi is 34 degrees. Actual temperature is 83 degrees. Okay? That means we have almost 50 degrees of superheat. So what we need to do is add refrigerant, because you add refrigerant to lower the actual temperature, and you remove refrigerant to raise the actual temperature. The pressure of the line is what gives us a saturation temperature. Okay? So that means at 105 psi, the refrigerant will saturate to a liquid at 35 degrees. The actual temperature of the refrigerant at that time was 83 degrees. So that means our refrigerant is superheated 50 degrees above its saturation temperature. Okay? So we are adding R410A. Always make sure whenever you're adding R410A that you charge it upside down. This is because R410A is a zeotropic mixture of R132 or R125 and R32. So, in order for that mixture to evenly disperse into the system, it has to be charged as a liquid, because R32 has a higher pressure than R125 naturally. So, we must always make sure and charge R410A in a liquid state. Now that we have added it in a liquid state through the suction line, always keep in mind too, whenever you're putting liquid into the suction line, always make sure and throttle it in. You don't want to slug the compressor with liquid. And you can very easily slug the compressor with liquid by charging liquid refrigerant, by fully opening the valve. So you just barely open the valve, and it throttles it in there. Now our pressure has went up. We are at about 135 psi, which coordinates to a saturation temperature of 46 degrees, and our actual line temperature is 76 degrees, which is 30 degrees. Remember, we had a required superheat at 24 degrees, so that means we need to add some more refrigerant. We need to add refrigerant to lower the actual temperature of the suction line. We only use this method of superheat with non-TXV devices like flow raters, piston valves, and so on and so forth. We never want to use superheat when we're dealing with thermostatic expansion valves, because thermostatic expansion valves require subcooling. So we have added a little bit more, and our actual saturation temperature is at 48 degrees, and our actual temperature is at 78 degrees, which is still 30 degrees of superheat, which is 6 degrees above what we want. We want 24 degrees, so we need to add some more. Anyway, once we reach that 24 degrees of superheat, we are done. And that means that the unit is charged according to how it's supposed to be charged, and is now operating at maximum thermal efficiency. That means that the entire surface of the evaporator is now being used to absorb heat from the apartment. If you overcharge it, it's not going to absorb very much heat. If you undercharge it, it's not going to absorb as much heat as it could, which is going to cause your unit to run a lot longer. Thanks.